Hello, I'm Thierry, and with me is Wen Hong. Today we'll be having a Unity 2D game development workshop. So, anyone of you attended the Intro to C# workshop yesterday? Do you have can I have a show of hands? Nice, yeah. If you attended the workshop, you'll be more familiar with the C# scripts that we will be going through. Yeah. So, let me share screen. Okay. So can you see my screen? Okay, yeah. So in the Zoom chat, there's a list of links that you can click into. So one of them will bring you to this the slides that we have, and also a folder of all the things that all the packages and things that we'll be using for this session. Okay. So let me just start. All right. So hi everyone. Welcome to the workshop. So first, we'll introduce what Unity is, and then we'll also guide you through the installation as well as some elements of game design that we apply in this room, in this game. And then we'll be moving on to the actual game development, where we'll be managing the game data and also programming the gameplay as well as the game menu. And then at the end, we'll provide you with more resources that you can view in your free time. So hopefully you've installed Unity, the Unity Hub, as well as the LTS 2020 version of Unity. Okay. So I would like you to click onto the link in the chat. It will bring you to a folder that contains a zip file that's called workshop participant. Can you all get this? Can you all see this zip in your own computers? So okay, so once you found this, then I would like you all to download this file. Okay. Okay. And as you are downloading, I will be talking about what Unity is and then what's the use of Unity. Okay. So what is Unity? Unity is a game engine. It's all-in-one game engine that's capable of rendering, having its own physics system, and also scripts to program the game. It's also cross-platform. That means you can create games in consoles like PS4, Xbox One, PC, and mobile games also. It is also completely free so long as your revenue is less than 100K. So it's really good for beginners and anyone or students to come in and have fun with Unity and make some games on your own. Yeah. Then it supports primarily C#. Those who attended the introduction to C# would be sort of more familiar with C#, hopefully. But it's okay for those who did not. We'll be going through sort of some of the basics a bit, and then we'll also handhold you to integrate you to the Unity programming environment. Okay. And also Unity allows for collaboration. Unity has a feature called Unity Teams, which allows different people to work on the project not really in real time, but to publish change and sync the changes between that. Yeah, something like GitHub for Unity. So yeah. Okay, so here are some of the games that's produced by using Unity engine. We have the very popular Genshin Impact, Animal Crossing, 2D platformers like Ori and Hollow Knight, so a survival game like Rust, and turn-based card game like Hearthstone. Okay. So hopefully you have installed the package. Okay. So once you have installed a package, can you see my screen? Navigate to your file explorer and find where your package is. So my package is here. Okay. Then I would like you all to right click and extract the package here. If you don't have WinRAR, it should appear as an extract all or something like that. Yeah. So you extract the package, and then you'll see a folder that's containing the workshop files, something like this folder here. Okay. I'll give you all some time to do that. If you all have any issues, you can say in the chat or just tell us. Okay, for those who have just joined, we are now at the stage of downloading the files that we need for the project. If you go to the chat, you will see a lot of links. One of the links will lead you to a folder that contains all the files that we have. Then I would like you to download the workshop participant zip file and then extract it inside your file explorer. WinZip expired. There's a default extraction tool in Windows. Does it work? Where do you find this? Okay. I need this link. Okay. Is it normal to have your computer lagging really badly? I don't think so. At this stage, no. When you open Unity, maybe. Yeah. Keegan, is your issue resolved, or do you need more help? Oh, okay. Do you see the link in the chat that I sent? It's the one that tells you to the participant files link. for Nicholas. So you click on that link, the participants file link, you'll see a zip file. Then I would like you to install this, to download the zip file and then extract it inside your file explorer. Can? And download. Yeah, you should download earlier. It's gonna take some time. Yeah. But it's okay. We'll if you can't catch up, we'll send a reference for you somewhere around the end of the session. Yeah. Download someone cancelled. What do you mean by cancel? Sorry, Nicholas. Mac laptops. Yeah, I believe so. You mean for extracting? Okay. No. Someone who knows how to extract in Mac OS, can you help ASS Joshua Amiraru? Oh, Michael. So do you see a link that you scroll up to the chat? Do you see a link that says participant files? Yeah, the link that Wenhong just sent. Okay. This participant files that Wenhong just sent. Now, can you click into the link? Yeah, the link, the bottom link, and then install the zip file. Then extract the zip file inside your file explorer. Right? Extract the participants files. Just extract it first. We'll be moving on soon. File explorer. Just hold on first. We will be moving on soon once everyone is fine with the extraction. Okay, I have to move on, sorry. Those that still have any questions, please direct it to Wen Hong. Yeah, I'll have to move on. Okay. Okay. So for those who have the zip file already, you should look something like this. Okay. So remember where you store the file at. Okay. And I would like you to go to your Unity hub, press add, then select the folder that you just extracted. So your folder may be in downloads or maybe in a document, and then you just open up the folder, right? Yeah. So once you open up, you'll be able to see the workshop participant here. Okay. Then you click into this, and your Unity will start to run. Okay.
Wait, sorry, Tia, can you bring them through the license? I think they can't open the file.
Oh, okay. The license, okay. License as in, okay, so go to your Unity hub and press the settings here. Okay, then license management, and then you have to activate a new license. Okay, then in this new license activation, if you have Plus or Pro, you can select this, but you need to have a license key, or you select Unity Personal, and then depending on what options you choose, you can choose this, then you say done, then you have a new license. Yeah. Oops. Yeah. Okay. So, okay, I'll be using personal. It's around the same as professional also. So hopefully you have the same as mine. Ken, any problems? Okay, yeah, Nicholas, is it license issue? Nicholas? Okay, if it's a license issue, yeah, Unity personal. So at Unity Hub, you press the settings, then go to license management, then activate a new license, select Unity personal, and you say I don't use Unity professional setting, and then just press done, and you'll have a license. All right. Does it work for the rest of you? Participant file. Higher than the file. Wait for it to upgrade the file. Yeah, you can just, if it's higher than the file, you select the version, then you have to, download. There will be like a download button here. You have to upgrade the file. Yeah. How to activate it? Okay. Go to your Unity Hub. Okay, then click on the settings icon here. And then there's this tab called license management. Click on that. And then press the activate new license. Then select Unity personal. And then select this. And then just press done. Okay. Yeah. Okay. So far, whoever that can reach this point, can you raise your hand so that I can have an idea of how's the progress? Okay. Cannot add the project. Oh, okay. So if you have the file that's that's still in the zip form, you right click the file, then there's an option to extract here. If you're using 7-zip, I think it's open with 7-zip. Yeah. Then you extract it wherever you want it. Downloading Visual Common. Harry, are you still installing Unity? Yeah. Because Unity needs Visual Studios to run. Yeah. Okay, I'll be moving on at 1 o'clock. So, okay. Yeah, okay. How to get the participants found in the documents? How, Nicholas, you can, if you download it inside your download folder, you can just drag it inside your documents. Is that your question? Don't know how to run Unity. Yeah. Yeah, Nicholas, you need to extract the file. Yeah, Unity don't take a long time. Yeah, that's why yeah, it's better to install Unity beforehand. Yeah. That's all right. If you cannot follow, we'll have at the end we'll give you a reference. Yeah. So you can see and then and also reference it to guide your own your own game. Yeah. Does it take? It's 60 MB around there. It should take quite some time, but not too long. Yeah. Okay, sorry, I have to move on. Okay. Okay, so okay, I'll be moving on. So can you all see my screen? Okay. So raise your hands if you can see my screen. Okay. Start. Okay. Okay. Now I'll guide you through the Unity interface. So at the top, we have the toolbar. So on the left hand here, these are set of tools that you can use. You can drag game objects, move things around. Then at the center is controlling the flow of a scene. Then at the right hand side is the accounts, your account, and layers are something like Photoshop layers, and layout is to change the overall look of your Unity. Then this hierarchy window is where you can see all the elements that is contained in a scene. So a scene is an environment that environment that you can run and see. Okay, so you can see that inside this game menu scene, we have game objects like main camera, canvas, menu controller, event system, all that. Okay. Then at the center is your game/scene view. This is where you can actually see what's going on as you adjust the game objects in the scene or when you are playing the game. On the right is your inspector tab. This tab, when you select a game object, you'll be able to see all the components of the game object inside this inspector tab. And then this inspector tab allows you to adjust the values of the properties in the game object. Okay. Then this is your project window. It's like a file system inside Unity. So it's similar to whatever file system that your OS is running on. Yeah. So we call it a collection of the scenes that you just installed and the scripts and basically the assets. Yeah. At the bottom is a status bar. It's a minimized view of console log that displays like user input messages. So if you are running code and then you have something that you want to debug, you can see it here. Yeah. Or you can go to the console, open up the console, which is much larger. Now I'll be showing you the game that we are going to make. Yeah. So you have a player, and the player will shoot bullets and kill the ghosts. The ghosts will be following the player. Then as the level increases, you can see the ghosts are gradually getting faster and faster. And also the amount of ghost spawn is also increasing. Yeah. It's a very basic game, but this basic game illustrated a lot of the concepts that you'll be working with when you're making a game. Okay. Okay. So before we actually start making a game, we need to brainstorm what are the aspects of the game that makes it a game. Okay. So in this game, we identify three primary concepts that we are utilizing. So we have a core mechanism, which is the player shooting bullet at the ghost. That's the core mechanism, the shooting. So in a first-person shooter, what's the mechanism? It's just a shooting and a first-person view shooting. Yeah. In a mobile game, it's there's a form of mechanism where you drag a player or drag a champion around the map. This kind of things. Yeah. So most of the games will have a fundamental mechanism to them that makes the game sort of have this repetitive element to it. Okay. Then we have a progression. So as the game progresses, in order for the player to get hooked onto the game, there should be some kind of increase in difficulty or adding on obstacle and challenges that the player needs to overcome. So then the player will have a sense of accomplishment when they overcome some kind of obstacles. Okay, so in our game, the progression is the scaling of the enemy. So the enemy gets faster, and also the amount of enemy that is spawning as the level goes on. We also have a reward system. The reward system is very fundamental to how a game is considered a game. Yeah, the reward, depending on the kind of reward, but mostly the reward that's used in games are sort of instant gratification. So once you accomplish a level, you receive some kind of reward. Once you once you open up a chest, you're able to see things that are in the chest, and then you can collect and upgrade your equipment, things like that. But for this game, we are using a basic high score system. So as you are progressing a game, your score increases, and at some point, when you overcome the high score, then there's like a instant gratification that you sort of achieve something greater. Yeah. Okay, so this is the game that's broken down into parts that's allowing us to see how the programming and the structure should be like. Okay. So at the top, we have gameplay and the game menu. These are the scenes that are available in the game. So for the gameplay scene, it's where the main gameplay is, where the player is able to shoot the enemies. Yeah, the basic, the game, yeah. Then the game menu, which is at the start, you will be seeing like a page, then it's tell you to start game, and then once you start game, you'll redirect to the game. Then when you die, then you also go back to the game menu and show a end menu that says maybe like play again or try again. Yeah, then you show the scores. Then of course we also need to have data. So we need to feed data such as the player score and also the player high score and also the high score of the game So the status of the game and like what level this game is at. And then this data can be utilized in all different parts of the game. Then controllers. Controllers are game objects that's very fundamental to controlling the flow of certain events. So these objects are it has to be there. So a lot of games that you have will have this kind of controller game objects, but it's user defined. That means you can control what kind of flow you want, what kind of events you want to put inside the controller or the menu controller. Yeah. So for the game controller, controls the flow of first the player spawns, then the player sort of navigate in the level, then switch of the level, and then afterwards transition to the game menu. The menu controller toggles different menus, toggles the start menu and the toggles the end menu, and also transition back to the gameplay. Then all this is connecting to it, it's the game objects. So these are game objects that's being controlled by the controller to accomplish some kind of effects. All right. So first, we will be talking about managing game data. So we'll be talking about the database, yeah, that's we'll be using throughout the game. But first, let's address some concepts of data. So there are different data types in Unity and in the native C# language. So the common ones in C# is integer, float, string. Those who have programming background will know them. Float refers to a kind of a decimal. Then strings are like text sort of things. Then Boolean is true or false, or it can be 1 or 0. Okay. Then there are also data types that are special in Unity, like vector2 and vector3. So vector2 is the coordinates of x and y. So it contains like a tuple of the x and y values as a game object, as the data. Then vector3 is XYZ direction. Yeah. And then we also need to know this fundamental concept that's very integral to Unity game development, which is the object-oriented programming. So actually everything that we are making are classes and objects in Unity. So what is object-oriented programming? To put simply, it's basically classes which are like blueprints. So you can think of it like the blueprint of a car, then also objects which are derived from the blueprint. So you can think of objects like the car itself that's manufactured from the blueprint of a car. Okay. So here are some of the classes that's used in Unity. They are inherited from mono behavior or static classes. Classes that are inherited from mono behavior is able to be used in Unity game objects. That means they are the dominant scripts in Unity. Yeah. But static classes are classes that are sort of on its own, that you cannot make more blueprints of that blueprint. Yeah. So they are sort of just there on its own unique. Yeah. Then for static classes, when you run it in a game, it differs from classes that are inherited from mono behavior because the memory of static classes is being stored throughout the game. So if I have like 1 MB of memory in a static class, that 1 MB will prolong through the game. So it takes up memory indefinitely. Yeah. And then another thing that's in C# is the permissions. In programming languages like Python, it's not very obvious, but in C# you have to define exactly what permissions are, which is the public or private. So for public permission, it's this class is able to be accessible by other scripts, and also it's an data type and data types and or variables that's declared using public is also accessible in the Unity component tab. Yeah, inside the inspector. Okay. Then for private classes, private permission, this kind of classes can only be accessible in that particular script. So inside that particular script, if there's other things that cause it, it runs. But in other script, it doesn't run. Okay. So so by combining the effects of the permissions and also the type of class, so if you use public, which allows other script to access, and we combine it with static, which means that the class is, or the script is unique, and we call it player data, we essentially make it into a database. So this is how a sort of a basic database system can be achieved in Unity. Okay, so I'll show you a demonstration of the properties of these permissions and things like that. Okay, so can everyone see my Unity? Can you raise your hands if you can show, if you can see my Unity? Okay. Okay, yeah. So now in Unity, when I click on scenes, data demo, you're able to see this data demo, and then there's 3 game objects that's available, the camera, then there's game object and script object. Okay. Now, when I click on the script object, you can see that there's a script inside called data demo script. Okay. When you press this 3 icon here, yeah, 3 dot icon, yeah, and then you press edit script, we'll be able to see this kind of this script here. And then this script is calling something called player data, which is the database that we made. And then it calls the property or the value for game status. So what exactly is this player data? Okay. Now, when we navigate to the assets and we go to the scripts, there will be one script which is called player data. Once we open the player data, you can see this are the things that are inside this class. So we have the score, high score, game status, which we reference here, and the public static, which is in and level count, the counting of the level. Okay. So once we call this, the default value is start, but we assign it to n, so we change the start to n. Okay, and debug.log sort of outputs the results of this thing that's in bracket, which is the value here. So it should output n to the console log. So when I run this, okay, when I run this, you'll be able to see at the bottom that it says n. So that's the status. That's the log bar, the status bar. Then, if you want a larger view, you can go to the console and you can see that this says n. And you can also see where does the code come from. All right. So that's how you reference the data inside the player data. Now, what happens if I set it to private? So if I have this as private, what would happen is inside the status bar, you'll see, give me a moment, it's compiling. Yeah, every single time when you change the code, it will compile. Yeah. So you can see, oh, sorry, I did not. Oh, also, and in the data demo, we uncheck this debug.log. You will see that this one is inaccessible to the protection level. So I'm trying to call this the property here, the player data property here, permission has in another script other than itself. That's why it doesn't allow me to access it. Yeah. And the thing about Unity is once you have an error here, you have to fix all compilation before you can actually run it. So always you have to check for errors and have to fix them promptly. Yeah. So that is how the permission is like. So now let's talk about the class itself. This kind of class is inherited from mono behavior because this part tells us that it's inherited from mono behavior. But for player data, see here it's static and static class and player data. So this is actually a static class. So what's the difference? I have another script called player data no static, and this one is inherited from mono behavior compared to the player data. So this one, which is inherited from mono behavior, what I can do is I can actually keep on putting it inside a game object indefinitely. And you can see if each of them is representing a database, we are creating multiple instances of a database. And we are starting to lose track of what exactly is the database. Yeah. On the other hand, if we assign the player data to this game object, you can see that it says that it doesn't have a native class image, so you cannot add the script inside anything. So that script itself is standalone and it's unique. And that's why we use static class. Yeah. So that is the class permissions and basically how the game data is like. Okay. So now we'll be moving on to actually programming the game and showing you and guiding you through how exactly to develop a game in a 2D game flow. Yeah. So Wenhong will be taking over.
Yeah.
Okay. Yeah.
Can you all see my screen? Yeah, so I think just now we forgot to mention. So on the first slide, there's actually 3 links. First is the slide itself, then you have the drive. So what does the drive have? Like if you're still stuck at downloading, we have an instruction document here, so you can follow. And yeah. And finally, the scripts. So now we're going through the programming of the gameplay, right? So it's very handy if you just it'll come in handy, yeah, if you just reference to this, if you're unable to catch up. Inside here, I've already pasted all the scripts, so yeah. All right. For now, I'll go back to, yeah, part 3. So let's move on to programming the gameplay. And what better way to start it than the player, right? And what do we want the player to do? If you just want a simple game, I think there are three basic states where we can make the player to do for our game today. The first being movement, and then because we want the player to be able to shoot, that's the second state. And finally, the death of the player to signify that it's the end of the round or the game. So these are the three states, and let's just start off with the movement. So if you go to your Unity, and under scripts in your assets folder, go to, you can see a list of scripts here, and just go to move and open it up. Yeah, so I'll just be explaining these lines. Yeah, so as Thierry has already said about public, you can actually reference from other scripts. But another unique thing about public is that you can actually access it from the inspector panel under Unity. So where is this inspector panel, right? If you click on player, and then you see that the movement script is attached. And this is the inspector panel. So I've already attached the movement script, and this is the speed that you see in the script itself. It's a public of float type, and I've called it speed. I've set it default to 5. Yeah. So that's the unique thing about this. You can actually change from the inspector panel itself instead of having to go through the trouble of going to your script and changing it manually. Yeah. And next we have the movement. I've set it to private. Without mentioning that it's private or public, it automatically defaults to private. Yeah, and it's a movement, it's a vector 2. So it's comprised of the X and Y axis because we only want the player to be moving in only the X and Y axis. Yeah, because it's a 2D game. I've called it movement. And the next is the public rigid of type rigid body 2D. I've called it RB. So what is this rigid body 2D, right? If you go to your Unity again, under the inspector panel, you can see that there is a component called rigid body 2D. And under that, if you click, there's body type, there's material, your mass, your drag, gravity, so on and so forth. So it basically provides this game object, the player, sort of like a form of physics for you to play around with. And for the gravity scale, I've set to 0 because it's a 2D game. I do not want the player to be falling consistently, right? Yeah, so that is the rigid body 2D. So then we have these two functions. And what is the update function? Update function is called once per frame. So depending on your device, if you're running a 25 FPS COM, then it's called 25 times per second. If you're running on 50 FPS, it's called 50 times per second. So that is the update. It basically consistently updates. It's basically called very frequently, yes. And then you have the fixed update function, right? Which I'll be explaining what's the difference. So for now, under the update function, sorry, what? The instructor, as an inspector panel, go to click on player. Then there's 3 tabs here. You can see there's services, is collaborate, that's inspector. And then just navigate to move script, and you can just change to 50 if you want. Yeah. Are you able to do that? I don't have to play. Oh, sorry. Under scenes, go to game and go to gameplay scene. Yeah. Under scenes, then the game folder. Yeah, then gameplay. Sorry, I forgot to mention. Yeah, so for now, under the update function, I want to update the movement, right? So for now, I'll just code. You don't have to code yet. I'll give you some time later. I'll set the movement x-axis to be equals to the input of get axis horizontal. So what is this, right? All right, before I explain this, let me just set the y as well. Capital V vertical. Okay, so this input is actually the input that the player has given us. So for example, you press the key S, then the input is S. Yeah, so depending on what keys you press on your keyboard, then it gives the input. So basically what we receive from the player. And how do we know if it's horizontal or vertical axis? If you go to Unity, under Edit, your top left hand, then Project Settings, there's this input manager that you can look into. And then you have your vertical, horizontal, a lot of variables here, right? And so what are these? These are actually because it's called the input manager, right? So from the name, you know that it's something that receives input from the players. So this horizontal axis is spelled with a capital H. That's why I spelled my variable names as horizontal with the capital H and V, to make sure that I'm referencing to this specific axis, this variable. And under the negative button and positive button, you have A and D. So what are these, right? So I'll be setting the player movements to WSAD, the common, the basic. And if we press A, it's moving left. So under horizontal axis, we want it to move left, so it gives us a negative value. And if we press D, then it returns us a positive value to signify that it's right. And the same goes for vertical. So vertical, then we have the negative button to be S, which is down, then the positive button to be W, which is up. So this is essentially how we obtain inputs from players. How do you get this window? Okay, under Edit, then Project Settings, and then Input Manager. There's a list here, and just click on Input Manager. Yeah, you're able to see all this. Yeah. Yeah, no problem. Then you have, so this is just the horizontal and vertical axis. This is how you receive inputs. So now that I've set the X and Y to be the input, right, depending on what we press in, I'm gonna use the function of rigid body. So, but before that, let me explain fixed updates. If we go back to the slides, okay, this might be a little bit complicated, but it's okay because it's your first time. Yeah, so the difference between update and fixed update is that update is very reliant on your frame rate. As I've said just now, it varies from device to another. So if you're running 25, then it's called 25 times, and 50 is called 50 times, right? And as for the fixed update, it actually it does not depend on the frame rate that your device is running on. So regardless of the FPS that you're running on, it's still called about 50 calls per second, and that's what makes it suitable to be used for game physics, because you don't want physics to be dependent on devices, right? Then it kind of like spoils the game. Yeah, so basically this is more consistent and this is less consistent, but in general, because they are both called update functions, so that's why they are consistently called. And so under the fixed update function, I would use the rigid body function, which I call RB here. I'll make a reference, and the function is called move position. This move position function moves basically the object to a certain position. And because it's called like multiple times in 1 second, so I can kind of make it like movements, tiny movement at a time, because it's gonna progress the longer it goes, right? So for this move position, it takes in parameters of the current position of the object, followed by it takes in a parameter of the position that you want it to move to. And because it's called many times, I want it to move a bit by bit. So it's the current position plus the movement, which consists of X and Y, multiplied by the speed that we want it to move by, and multiply by time dot fix delta time. So what's this fix delta time, right? This delta time thing. Let's go back to the slides. So delta time is the amount of time taken to render the last frame, right? So, okay, for example, I'll be using the update function. So if we don't use delta time, we will be achieving these things, right? So if you're running 30 FPS on your comp, then it's 30 frames multiplied by the speed that we have set to, which is 5, and that will give us 150 units per second, which we do not want. What we are aiming to is achieving 5 units per second, regardless of your computer, right? And if you're running 60, it's 60 by and then 300. Whereas with delta time, is 30 frames again, multiplied by 5, multiplied by 1/30. So what is this 1/30, right? Is the amount of time that it took to render the last frame. So because there are 30 frames in 1 second, so one frame is approximately 1 out of 30 seconds. And that's why it cancels out with your frame rate. And then it gives you a 5 units per second. Right. It works the same with 60 FPS. We have 60 frames rendered 1 second, then one frame is about 1 out of 60, and therefore it's 5 units. So essentially, this is what our delta time is. It's okay if you find it tough to grasp in the first few stages, but as we go on, I think you'll be able to understand. So for now, if we save this file and just click on play under the gameplay scene, you can see that WSAD is it's working. Basically, the play can move now. And the other thing I want to introduce is this get axis, right? There's actually to illustrate what this get axis is, I'll just print this out. Yeah, so if I click on play and under the console, there's things that's printing out, and now it's just printing 0 repeatedly because there's no value. But if I press on A, it gives me a list of values here. It's not -1. It's the range. Is the range between -1 to 1 for this get axis. So because I press left, it gives me a range of values between -0 point something to -1. Yes, and this is because it goes along with the duration that you're pressing on your key. So let me just go to the latest. If I press right consistently, it'll give me 1. But if I release it, then it gives me kind of like a decelerating value kind of thing, right? It goes slowly back to 0. This is what get axis is. Sorry, what? How do you add the player model? Oh, player, as in how do we get the player to be of this icon? This is. Oh, okay. We did it by using okay, so first we create the game object by right clicking here and create empty. And then there is a component called sprite renderer. And under sprite renderer, there's this sprite, and you can just drag it to this. Yeah, this is how they get the image. Yeah. Oh wait, where was I? Wait, sorry. Yeah, get axis, right? So there's another function that only returns us either a negative value or positive value depending on what we press. So this other thing is called raw. So raw basically means we just want the raw value, which is either -1 or +1. So I'm gonna put the horizontal to be get axis raw, and you'll see what's the difference if I use get axis raw and get axis. Yeah, bear in mind that the vertical is still get axis and the horizontal is raw. So if you click on play, then if I press left, it immediately returns me -1. And if I press right, then it gives me 1. So this, you can see that from the scene itself, model. Yeah, I'll show it after I finish this part. Yeah. So if I press left, it immediately moves, and I press right, it immediately moves. So there's like no drag, no acceleration, what kind of thing, right? Whereas if I press up, it slowly moves up, and I press down, it slowly moves down. So this is the difference because depending on the value, right? As you see just now from get axis, it gives me a range of values between -1 to 1. Therefore, there's this kind of feeling of acceleration. So yeah, depending on which one you want, you can use the function. But for today, I'll just be using get axis to make it slightly more interesting. Yeah, so there's this acceleration thing. Yep. And next, I think we'll be going into the shooting part. Oh wait, sorry. Yeah, now you can take some time to catch up with this script if you have yet to. And if you have any questions, you can ask in the chat. I'll just give like 2 minutes. Oh yeah, sprites. So you can ask them as well. Stay back after the workshop. Are you asking us after the workshop or? Okay, yeah, sure. Yeah, if you want to just directly copy, or if you cannot catch up, then you can always reference to the script, the code snippets document, where you can just get it here. All right, so for the sprites again, it's under player. Sorry, you create a game object and then you call it like player. And under game object, under the inspector panel, you have components, right? You can add component, and then you search for the sprite renderer. Sprite render. And in the sprite component, you can just click and drag whatever PNGs you have uploaded. When's I was trying to this DME when you finish season? Oh well, sorry. Yeah, then you can just click and drag whatever image that you've uploaded and into like here. This is sprite renderer, the component. For today is not like the main part, so if you're interested, I can always go through again after the workshop. Yeah, so for now, I'll just move on with the shooting part, right? All right. If we go again to the script, I've set the shooting part to be under weapon.cs or C#. And we have a list of variables here again, and the functions below. So before I go into that, I just want to go through like how the shooting function works. First, to determine the direction that we want to shoot, we need to have two things. We need to have the axis, the horizontal or vertical axis, and we need to have the direction, if it's a positive or negative direction. Then we can know where it's up, down, left, or right. So we determine the direction, and then we determine the position of where we want to establish the bullet. So we have this bullet, right? We want to shoot it. So we need to establish the position to spawn this bullet first, and then we instantiate that bullet at that position. And after which we apply a force to that object to send it flying in the direction that we want to. So first we have the axis and direction, then we get the position of the bullet to be instantiated, and then we spawn the bullet there, and then we apply a force in the direction to let it to get it flying. All right, so I'll just go through these variables really quickly. All right, we have public of type game object called the bullet prefab. what is a prefab, right? A prefab is a prefabricated object with its respective components and scripts. So I have this ghost prefab here, and it has its own sprite renderers, its own transform, rigid body, colliders, scripts. Yeah. So this is an object that has all these components, but this object is not in the scene itself. That's why, yeah, so it's called like a prefab. So if you want to instantiate this object in a scene, you can actually instantiate this object with its entire set of properties without having to adjust it or manually drag it into the panel. Yeah. So it's what a prefab is. And then we have a bullet force that I've set to under player, the weapon script. I've set the force to 20. So if you want to have it slower or faster, it's up to you. And I have the reload time to be default to 0.25 seconds. This reload time is to just prevent the player from being able to repeatedly shoot without like any form of cooldown, right? And then I have a Boolean is reloading. Boolean returns true or false, and if the player is reloading, then it's true, it's not as false. All right, so when the scene starts, I want to set is reloading to false because the player has yet to shoot any bullets. And in the update function, I want to be consistently aware of whether the player is reloading or not. So under the update function, I'll type in the conditional if it's reloading. Then I open. Then I want to return. So what is this return? Return basically is just to return, because I didn't insert anything, so it's just return nothing, and therefore it gets out of the function. Therefore, getting out of the function basically means whatever code that you have written, like below, like here, it won't run because it would just return, yeah. So if the player is reloading, I don't want to run this function. I just want it to get out. All right, then if the player is not reloading, then it won't return, and then it will carry on running the functions below. So if the player is not reloading, that means that we're able to shoot. So I get the conditional if the input dot gets button down to check whether the button that the player has pressed is of the button type called fire1. I'll show you what fire1 means in a second. And then I will do something, and else if the dot get button down fire2, then I want to do something. So if you go back to Unity, because we're once again accessing the inputs from player, so we have to go to edit and go to project settings again, and under the input manager, there is fire1 and 2. So if you click fire1, if you open up fire1, it's actually just the buttons left and right in the negative and positive direction. It returns a negative value, then positive value, right? Then fire2 is up and down. So for this one, I just make it to like the horizontal axis, so it's left and right. And the fire2 as a reference to the vertical axis as up and down. And it will return me the respective values depending on what I press. Yeah, it works the same with the horizontal and vertical. So, all right, so once we have the button down, which is either left or right, then we want to shoot using a function. And we need to take in two parameters, which is the axis and the direction, right? If it's positive or negative. So then we have the axis as horizontal and the direction as the input dot get axis raw, because I just want to obtain the value that we have fired in. So it's either positive 1 or negative 1. So I'll just set it to be fire1. Close the statement. And for this vertical, axis raw. Yeah. So you guys can take some time to just catch up with this if you have yet to. I don't understand for 1.2. It's just variables that I've set in the input manager to make a reference to whether or not player is firing to the horizontal axis or vertical axis, and the value if it's up or down. So in the settings, it's in the input manager. It actually works with the same as horizontal and vertical. It's just that instead of typing horizontal, because I already used the word horizontal, I'm just using 1 and 2. 1 is the horizontal axis, and yeah, depending if you press left button, then it gives me a negative button under the variable fire 1. How do you get fire 1? You can if you don't have it, you can actually rename these by using the name. So depending on what you want, you can always rename it. How do you create another variable? Fire random direction. For random direction, it's actually more of using mouse, but for today, we won't be using that. So if you want to explore more, you can like Google it yourself and explore more, because I'm also not very sure about the random direction. It's more on the mouse input instead of buttons. Yeah. If mouse is pressed. No, I think mouse is a different input. It should be sorry, I'm actually not very sure about mouse inputs. Yeah, for today we will just be using keyboard inputs. Yeah. I'll assume that you guys have caught up. There's a mouse 0 and mouse 1 settings. Mouse X, mouse Y. Yeah. You could try that out.
Well, I think he's asking for the one inside the fire one.
Wait, which one?
Inside input manager.
Sure, right?
Input manager, yeah. Inside you see this
mouse 0. Yeah. Okay, I see. For today, because we're not using mouse, you can actually delete it. But I mean, because
you can actually assign the mouse there. Then you can use the mouse to shoot instead. So you assign it inside the negative or the positive part then. Yeah. So you can change this to a mouse if you want to. Then you will be using your mouse to shoot. Yeah.
Yeah, but I think because mouse only has 2 buttons, so you can't really identify 4 directions. Yeah. That's why I'm using the keyboard. Yeah, can I assume that everyone has caught up? If you have yet to, you can refer to the snippets. Yeah, so now I'll be going through the shooting function, right? We have this: if the axis is horizontal, then we know where to is on the horizontal axis, and if this direction is not equal to 0, it's just for a debugging measure. I'll illustrate to you in a while, so I'll just remove it for now. Okay, so when we shoot, we want to set where the position of the bullet to be spawned at, and so I will call this a vector 3, because positions are defined in vector 3, and I'll call it bullet position to be assigned to a new vector 3. And I'll ask to determine the position, right? We don't want the bullet to be instantiated right in the center of the player. I want it to be slightly to the right or slightly to the left to make it looks like it's shooting. To make it looks like it's shooting up. So instead of just game object, the game object means the object with the script attached. So it's basically the player's. Yeah, so it's basically the player, and I'll reference it to the player's transform position. This transform position basically is if you click on player under the gameplay scene, there's a transform component, and you can see that there's position, rotation, and scale. So you can adjust it if you want. You can adjust the scale, yeah, the rotation and position. So our reference to the position, and specifically the X component, and I want it to be established like slightly to the right or left because it's horizontal. So yeah, plus maybe 0.5 f multiply by the direction, right? Depending on the direction. So it's basically the position of the player, the X position, plus this value multiplied by direction. Direction is a -1 or +1 value. So if referring to the left, then it will go to minus 0.5. If you're referring to the right, it goes to just plus 0.5. Yes. And so for the make it look neater, game object for the y and z axis, I'm not adjusting it, so I'll just reference to the player's y and the player. Yeah, so this is basically establishing where the bullets is to be spawned. And then we want to generate the bullet now. Now that we have established where we want to instantiate the bullet, we're going to use the function instantiate. So I will call this game object bullet. I'll use the function instantiate. Instantiate is to just create an instance of the object. So what am I instantiating? I'm instantiating the bullet prefab. And this bullet prefab, if you look at a panel, in the weapon script, there's this bullet prefab. I've already assigned it, so I just click and drag here. I already did that, so you don't have to do that. And basically, it's a prefabricated object with its components and its script, which I'll be going through. Yeah, so I want to instantiate this bullet at position. And with when you instantiate, you need to also mention the rotation, in which case I'll just set it to player's rotation, which is 0. Transform the rotation. Yeah, so that's how you instantiate it. So if I save the file, I'm just going to click on play. Yeah, if I press left, it's just gonna instantiate. Yeah, slightly to the right of the player. It's just gonna spawn the object there. It's just creating an instance and does not do anything as of now. So this is what instantiate means. And after we instantiate, we want to apply the force, right, to get it flying. So we need to set the direction to apply the force. In which case, I'll call it a type vector 2. I'm going to call it aim, and it will be in the direction of a new vector 2. Because we're firing on the horizontal axis, so I'm just going to set the direction, a positive or negative value, to multiply by the bullet force that we're going to apply, which is 20. And for the y-axis, it's just 0, because I'm not firing in the y-axis, and I'll just close it. And finally, we apply a force, right? I'm going to reference to the rigid body again. Sorry. It's called RB. Sorry. I need to first get the rigid body first. So to do that, we need to get in a rigid body 2D of type. Of this type, and set RB to get components of rigid. This is how I make reference to the rigid body of the player. Yeah, and after that we have reference to that. Oh wait, sorry, this is not the player. I want to reference to the bullet because I'm applying a force to the bullet. And then I will use RB.addForce, which applies a force in the direction of aim and of type force mode 2D of impulse. There are other types of forces, but for today we'll just be using impulse because it's an instant force applied the moment that we fire it. So if we save, and you click on play, you should be able to fire depending on where you want to. And there's this oh sorry, I haven't added the vertical part. Yeah, so for the vertical part it's the same thing except in the vertical direction. Yeah, so we can just uncomment that. And just now I said about the direction not being equals to 0, right? Is because if you do happen to press left and right together, it actually returns you a value of 0. Yeah, in which case you just instantiate that and not move. So it's like a form of debugging. Yeah. So I do not want that. So I just set the direction not equals to 0. So double ampersand is just n equals to 0. Yep, so long as there's no errors in the codes. Yeah, so for now, if you can take a moment to catch up on this, yeah, can refer to the code snippet as well. I'll give about like 2 minutes. I am not sure about that. Yeah. Oh, sorry. I downloaded I downloaded C# for Visual Studio Code and debugger for Unity. I think there's a third one, but I'm not sure if it's useful. It's like Unity code snippets. I'm not sure if that's useful. You can try it, I guess. Yeah. All right, I'll be moving on. You can refer to the code snippet if you're unable to catch up. All right, so we need to set the reload time, right? Yeah. After we shoot, we want to get. I'm using coroutines to set as reload time. And what is a coroutine? If we refer back to the slides, coroutine is a subroutine. You can call it a timed function. So you notice how when we execute functions, when we run functions, it immediately just run the whole piece of code, right? It does not have any delays. Whereas for coroutine, it allows for execution of functions to be suspended and resumed. So what does that mean, right? That means if I only want to run like maybe like I don't know this code, I just wanted to instantiate, then like after 2 seconds, then we apply the force. Yeah, then we can use coroutines. So it allows for like the code to just stop here and then like wait for a while and then it continues moving on to the rest. So that's what like coroutines is. It allows for suspension and of programs and resuming whenever you want. So I've created a coroutine of called reload. It's below. Don't worry much about enumerators. For this case, you can just take it as like a way to define coroutine. So after we shoot, I immediately start the coroutine. And what do I do in the coroutine? coroutines allows you to use this specific function. It's called yield return new wait per seconds. It's basically the function that allows you to wait for a specific amount of time before moving on to this next piece of code. Yeah. So when I go into this function, I set the is reloading to true. So what does this is reloading to true do? Basically, if you go back to update, because it's consistently called, if we set it to true, then it'll run this function, which is just return. You run this statement, just return, which means it will not process if the user has pressed in any inputs. So if it returns, then it just gets out of the function and it gets out and gets out. So after this reload time expires, which I already set it defaulted to 0.25, you can extend it or minimize it if you want. Yeah, I set it to 0.25, so it will wait for 0.25 seconds, and then it sets the is reloading to false. Your question, yeah. And that's how we kind of like use the reload function, kind of like execute it. Yeah. So we shoot already, then we immediately start the coroutine. So we set it to true, we want the player to reload, and then we wait for 0.25 and we set it to false. Yeah. Just take about like maybe 15 seconds to catch up on this code. Yeah. So we have handled the player side. Next, I'll be going to the bullet itself, the prefab. Yeah. Could you send the codes? Yeah, it's in the code snippet. It's in the slides. The first slide, you can see that there's this script link. Wait, never mind. Let me just copy this. Yeah. Okay, so now I'll be going into the bullet script itself. Before I do that, I've mentioned about bullet prefab. So it's basically, it has its own components, right? And there's this script attached. And let's just go into the script. It's called bullet.cs. Yeah, so I have a bullet duration because for the bullet itself, I don't want it to forever stay in the scene, right? I want it to expire after some amount of time. Because if you actually look at, if you actually play it, and when you fire it, it's instantiated here, and you just forever be moving towards the right. And if you press another one, it keeps instantiating and does not disappear. So it kind of like eats up the memory, and it's not very efficient as well. So the more times you press, I think it consumes more, and that's not what we want. So I want it to disappear after some time. And therefore, that's the bullet duration. How long I want the bullet to stay in the scene for, yeah. And then I have the fade time. Fade time, I'll explain it in just a while. Okay, so for bullet itself, in essence, whenever it touch any objects in the scene, I want it to disappear, right? So there's this function called onTrigger enter 2D. It basically sends or detects if the bullet has collided with any objects at all in the scene. And yeah, so it takes in a parameter of type collider2D and other. This other basically refers to the other object that we collided with. But for this function, we're not really using it because yeah. And so when I collide with another object, I want to destroy game objects. Game object refers to the bullet itself. And yeah, so if you run, oh wait, because I don't have any objects yet, so yeah, I can't show it for now. Yeah. So in the start, I want to set a fade time. This fade time is the time that I set for the bullet to expire by. So it's basically time.time, which is the current time, and then it plus the bullet duration. So basically, it takes the current time. Let's say for like example 2009 now, and maybe the bullet lasts for a minute. So at 2010, it will expire, or at least this is the fade time. Yeah. So this is how basically how the thing works, right? So obviously you won't have 1 minute, so it's gonna be like a few seconds. So it's the current time plus the number of seconds, and then that's the fade time. So to do that, I want to consistently be updated whether the current time exceeds the fade time, right? So I'll use the conditional if dot time is more than fade time, and I will destroy game objects, right? So if the current time is greater than 2010, then it will just destroy the object, remove it from the scene. Yeah. Yeah, you can take some time to catch up now if you have yet to. And if you have any questions, you can yeah, ask chat. How do you tell what game object is? Okay, oh yeah. The smaller g refers to the game object that has this script. Yeah. So if you're finding another game object, you use the capital G, game objects dot. If you want, I don't know, find with tag, something like that. Yeah. So in this case, this game object does not refer to the object that contains this this script, that has the script. Yeah, the lowercase g is the one that has the script, and therefore I reference to this object. Oh, it's basically in the C. So if you go and look at bullet, and under the inspector panel, if the bullet script is inside as one of the components, that means it contains the script. It has the components of this this bullet script. Yeah. Let's come back to, I don't know, ghost. It's not. Yeah. This is how you see if the player has specific components. Yeah. Okay, multiple object reference is the same script. Yes, but when multiple objects have the same script, that means these objects all have they all have these functions. Or different objects. Yeah, like because if you look at the ghost and bullet, because for ghosts, I don't want it to disappear when it touches like anything, right? The ghost, I want it to stay in the scene. So I don't want to have the ghost to have the script, if you're asking that. I mean, they can have, but if the ghost, because the ghost will also have things like on trigger enter 2D. So if it collides with anything, then you also destroy itself, which I don't want that to happen. And the ghost will also have a limiting time in the scene. Yeah. So yes, you can have different objects having the same script, but yeah. Okay, so I'll just move on. Sorry, this. Yeah. For now, we're done with the weapons and the shooting itself. So then let's move on to finally the death. All right. If you look at the script again, sorry, it's quite dry. Yeah, but the death script is very, very short. So just bear with me for a second. Okay, so for death, when the player collides with only ghosts, right? I don't want the player to collide with anything and then it dies. So I only want a specific object that sets the player as in death state. Yeah. So I have this on collision enter 2D, and it has other as the parameter. So if other.game object, the tag is ghost, then I want it to die. So what is this tag, right? If you go back to your Unity, go to ghost prefab under the project folder in assets under prefabs, you can see a ghost. And if you click on it, you can from the inspector panel, you can see that there's this tag called ghost, which I assigned it. You can add tags if you want. Yeah. so on and so forth, right? So I've already assigned it to ghost. So if it collides with, if the tag is ghost, and then we'll proceed with these few statements. So when the player dies, I want to first reset the level count. So I'll reference to player data dot level count. I'm just gonna set it to 1 because it starts from 1. And then I want to set the status of the game to be end. So it's player data again dot the game status equals to, and finally I want to load the end menu. The end menu is basically if you look at the scenes, and under game there's this game menu. Yeah. So this game menu is basically the one that shows your high score and your game over, so on. Yeah. So I want to load that scene. So I just reference to the game manager. It's called the scene manager, sorry. Called load scene. And then because we call the scene to be game menu, so I will just have to type the exact words with its respective caps. Yeah. So it will load that scene when the player collides with a ghost object. It will set the count back to 1 and set the status to end, as well as load the scene. Yeah. You can take some time to complete this as well. Yeah, for dev, that's basically it. Then after that, yeah. So for now, we'll be taking like a short 15-minute break. Yeah. So if you have any questions, you can post it in the chat during the break. You can also try out the scenes, adjust the values, play with the scripts. Yeah, it's like free time basically. Yeah. I'll start at about 2:32. Where do we write the code? Which code are you referring to? Or are you saying where do you reference the completed code? If you're saying where to write, it's in the scripts that I've already created in the scene. Yeah. Like yeah, under the project folder, you can see that there's a scripts and then there's a list of scripts. Yeah, just write it here.
Adding the enemy, we'll be covering the enemy next, as well as the high score things next. Wilhelm, can you go through again the dev part? Wilhelm,
Yeah. Wait, just give me a second.
give a brief overview of the dev.
Or okay. Wait, which part? Which
The
the
dev script.
the dash script. Okay. Which I just go through everything.
Yeah.
Okay. Okay. So the player. So to begin with, right? The player. If you go to the scenes under game and gameplay, I've already assigned the dash script to the player. Yeah. So the player also have this component, right? That we want the player, if the player like touches a ghost, then we want it to die, right? So if there's this function called the onCollision enter 2D, is if it collides with an object, and if this other object that we collided with, if the tag is ghost that we identify with, then we want to run the statements here. So that's how the function works. If we collide with ghost, then we want to reset the level count. And this player data is basically the small database that we made. We have the game status, with the levels count, the high score, and the score. Yeah. So what I want to do is to reset the level count to 1, because it's gonna begin to from 1 again. And I'll set the game status to end instead of start here. And I want to load the scene game menu. This game menu scene is you can find it in the folder as well. It's called the game menu. Just double click and you can see that it shows you the high score, the game over, scores, and play again. Yeah, this is what the load scene does. Yeah. Do you still have any questions? How do you enable the dash screen? Enabling is if you go to where's player data? Oh, you can find it in the scripts folder. Under then enable dash script. You go to the scenes in the game folder and the gameplay. Click on player. Then it's just like automatically enabled. I guess yeah. I'm not sure what you mean by enabling the dash script. What's the main camera? Okay, so you notice how when we click on play, right? Then we're set to this width of camera size. So if you click on camera, I'm gonna unplay it. If you double click on camera and go to scene, you can wait, sorry. Yeah, it shows you like the area that you are able to see. But that's the thing about the canvas though. The canvas actually is shown here instead of the scene itself. Yeah. So main camera just shows where you the dimensions of where your player is able to see. But I mean, we don't have to really adjust it. Yeah, because the canvas automatically fits into the main camera. How do you create your own game object? I just right click on the hierarchy panel. Then you can see the create empty. It's basically a game object. Anything in the hierarchy panel is basically a game object. Yeah. Then yeah, you just create it here. You can change the name. You can assign components if you want.
Okay, we'll be starting soon. Are you all here yet? If you are here, please raise up your hands. Okay. Okay, I'll wait for like 1 minute more. Okay, we'll be starting. Hopefully you all are here. Okay, so that huge chunk is the enemy. So is the player. So now we're moving on to the enemy, which is can say is simpler, but it's more of a sort of more conceptual. Okay. So let's think about what the ghost actually does. The ghost actually follows the player, and the ghost can also die. So how does the ghost follow the player? For this game, we are using the A-star pathfinding algorithm. So what this is algorithm that match the 2D space into a graph. So an if you're doing a 2D game, then it's an XY graph. So in this graph, you see that it's dividing into tiles of square. Then each tile represents a node. Then in this node, the algorithm will match out a path, the shortest path to reach the target. So for example, the rate to reach the green. Okay. Then there's also other kinds of pathfinding algorithms which we are not using. They are like naive mesh, which uses polygons. Usually polygons are found in 3D kind of games. So if you're playing 3D games, all those models that you see in 3D, they are actually made up of tiny little polygons that's meshed together in a wireframe. Yeah, quite complicated, but naive mesh sort of maps out the entire layer of polygons and store it inside memory, so then it allows the different objects inside to travel the transverse in the path. Yeah, but for our case, A-star pathfinding is the easiest to implement, and it's also quite fast for it to run. Okay. So now going to the code. Can you all see my Unity? Okay. Now, first inside gameplay, we will need to create a new game object. So we create an empty game object, and let's call it A-star. So what this game object we want it to do is to map out the area. So this one creates an environment for the algorithm to run. So inside this A-star game object, under the inspector tab, we add a component and we find pathfinder. Everyone follow? I'll require you to follow along because this part is not in the code snippet. Okay. Then once you have this here, open up the graphs. Then you add a new graph. Yeah, the grid graph will represent A star. There's other kinds of graph which are different. The rest like the leaf mesh and other pathfinding ways. So you select the grid graph, and you can see this a lot of options that appears. So what this pathfinder is a package that's in Unity to help you sort of navigate. So all these options, a lot of them are useful for different situations, but what we focus on is more of the 2D features. So in the grid graph, select the 2D. Let me just show you.
Wait, Jay, can you repeat? Yeah.
Which part?
Like the whole thing. Yeah.
How I get here? Okay. So you open up gameplay. Okay. Then you create a new game object that's empty. Okay. Then inside this game object, you add a component. Then inside this search bar, you search for pathfinder, and you select the pathfinder. Is it okay? Can I follow? Okay, yeah. So once you have that, let me delete this. So once you have this A starting, so you have this graph. Select 2D because you are using a 2D environment. Then, okay, let's zoom in here. I'll show you what happens. So if you don't select 2D, it's a flat line. Why is it so? It's because it treats the graph treats it as an XZ kind of graph. So if it's XZ and we are in the XY graph, right? Then this one is just a line. So we need to fix this to 2D. Then you throw this square tile here. And this square tile, as you can see from the slide, it looks very similar, something like that, yeah. Then the environment, we need it to be either the same size as the camera or bigger, so that the goals have space to travel in. So to adjust the size, you'll use you can click on here and then you just drag. You can see this expanding. Okay. Then the depth, which is the width or the height, sorry. When you drag this, it's also expanding. Yeah. Then I think this is fine. Yeah, should be good enough. Okay. Then next, this is all the things that are quite, a lot of them we don't really need to use. Then when we look at here, use 2D physics. We will need to use 2D physics. Then we select this. Then a lot of options disappears. Yeah. All right. So in the grid graph, what you do is first you select 2D, then you change the width and the depth of the nodes to give an environment like this. Then you select 2D physics. Okay. Once you have that, then you scan the graph. You'll see a blue color kind of outline, or blue color area that still has those dots or square tiles. All right. So that is the environment that the ghost is able to navigate in. Okay, so let's add a ghost inside. For example, let's add a ghost. So inside assets to prefab, then we drag a ghost inside. The ghost is not really if you run this, the ghost isn't really doing anything because the ghost doesn't know where to navigate to. So how to set this target to the ghost is we go to ghost and scroll down to the AI destination setter. Okay, then this target, we need to assign it to the player. So it goes here, I assign it to player. Cannot assign because we open it in the prefab. So instead we need to open it in the hierarchy tab, this one. Then we assign it to the player. Inside the AI destination setter. Okay, can you all follow along? Do you need me to repeat? Okay, I'll pause for a while. Okay. Then when I play thing, okay. So you drag the ghost prefab into the scene, you'll have all these options here. So inside this AI destination setter, in the target, for if you don't have the player, it will be none and then bracket transform, something like that. So how you select the target is you drag the player, hold this, drag it, and just snap it inside the target. Right, okay. Then when you press play, what happens is you see the ghost moving towards the player. And I can move the player here, the ghost will still come. Move the player here, the ghost will follow automatically. Yeah. And if you want to know what the path looks like, you can click onto the seeker. You'll see this kind of path. Yeah, that is the path that you see in the slide also. Where do you drag it from? Drag the player or the ghost? What do you mean by drag it from? If we're talking about the ghost, why is there a ghost here? Is yeah, because so how you get the ghost is you go to assets, then go to the prefab, then click on this, and you drag and hold this to the hierarchy tab, and just paste this. Then the ghost is here, and also here on the scene. Is that all right? And then you assign the player by dragging, clicking this. When you click on the ghost and you see the inspector tab, you see this AI destination setter. Do you see this? Then there's a target that is called none. So what you do is you click and hold the player, then drag it inside this target. Then you assign the target to the player, and so the ghost will now we press play, track the player. Okay, the ghost is not following. Do you set the target as a player? Ghost is not following the player. Is your ghost appearing on the scene? It's outside the black box. Outside the black box. Or like around here. Okay, when you go to your A star, do you scan the graph? Okay, do you scan the graph in the A star object? So you go to the A star and scan. Okay, that's a bit strange. Not sure what's the error yet. Wenhong, can you voice call him? Yeah. Okay. So sorry, we'll move on. So hopefully you've get the goals to be able to pathfind to the player. Okay. But the thing is, the ghost doesn't always appear in the scene. So sometimes the ghost will be spawned inside the scene. And when the ghost is spawned, the target is automatically set to null. So when that's the case, we need to force the target to become the player. So how do we do that? Is we go to the assets, then go to the prefab, go back to this ghost prefab. Okay. Please note that this ghost prefab is different from this ghost here. Okay. If you are confused, you can delete this ghost away. Yeah. And under prefab, click on the ghost. When you scroll down to this destination setter, open it up. You edit the script. Now the code is inside the document. So when you scroll down in the update function, there's a lot of documentation about this. You can go and read up if on your own time. Yeah. So under this update, you can see that this is where the target is being set to the position. So the destination of AI, where the AI or the ghost is supposed to go is set to the position of the target, which is the coordinate of the player. So we need a way to force this to be set on the player. So what we do is we can just type, we check whether the player exists. So if the game object find player, so this checks whether the player exists. If this returns some value, the player exists. If this doesn't return anything, it will become null. And so this if statement will not run. Then inside here, we need to set the target to be equal to the position of the player. So what we do is target equals to, you can copy and paste this. Transform. Lowercase transform because it's a component. Okay, so transform is a component inside the player. You can see it inside the player inspector tab. When we open up a player in the inspector tab. So what this transform component contain is the sort of like the positions and other things that the target has. So one of the things that is under transform is the target position. So that's why this one is set to the player if we are using this to force it onto the player. Okay. So once that's done, compiling script. Okay. So even if I add a lot of goals inside, like a lot of here, and I don't set it to, in the AI destination setter, I don't set the target to anything. I don't need to like drag it to here. And when I press play, they'll all navigate towards the player because of the function that I write just now that sets it to the player. All right. So take some time to copy the code. I can type the code in.
Wait, is it possible to get the participants to share their screen if they have any like bugs?
Or you can Discord him in the voice chat. Yeah. Okay. Another thing to note is that I can. Yeah. Do open the breakout room. So Wei-Hong can help out with the bugs. Wei-Hong, can you text Yohan?
Yeah.
Okay, so moving on, there's nothing that you have to note. So under prefab inside goals, there's this AI path script here. So what this does is the algorithm itself. So just now the A star object is the environment. Then this one is the algorithm itself that allows the goals to navigate. Okay, so at this A star path, you can change the speed of the path finding. So I can set the speed to very high and the goals can move extremely fast. Yeah. Okay. So now we have the goals being able to path find. Something else that goals sort of do is for it to kind of just die. Okay. So inside the goals prefab again, you'll see another script which is called the enemy script. So I would like you to edit the script. Then here, you see that on trigger enter 2D, this script looks oddly familiar to the one where the player dies. If we try open up, yeah, it's sort of similar, quite similar. But instead, for the enemy, we need to check collision with the bullet instead of the goals. So it's if other that goes to bullet, then what we do is we sort of remove the goals by destroying the game object. That means we actually remove it from the scene. So destroy, forget. The goals is the game object itself. So we can refer to the goals as the game object. Okay. And since the goals die, we'll add a score to the player's score. And to do that is we refer back to the database and the score element, and we set it and add it to 1. And that's how the goals death script look like, an enemy script. And if you run this, I'm lagging. Oh yeah, I forgot. I can add some goals in first. Okay, so I'm best play. See that when I shoot the bullet, the ghost disappears, and the score also increases. And that's all for the ghost part. So here's the code. I also need to copy. You can always copy in the code snippet. Or any questions? Okay, so next part is the game controller. So Wonhong will be talking about the game controller script, which is controlling the overall flow of the game itself. So now we have the goals done, we have the player done. We need a way for the level to transit and for the goals to spawn in.
Yeah.
Yeah. So can share. We'll be sharing screen.
All right. So I'll be going through the level system for now, and it's mainly comprised of just 2 main functions under the game controller. These 2 functions are the spawner and the level duration. Don't worry about the names. Yeah. So for spawner, it's mainly just to repeatedly spawn the ghosts at the scene, as well as to control the rate of spawning. So as the level goes higher, then we want a more frequent rate of spawning the enemies. And as for the duration, it kind of handles the rest of the thing. So for example, like showing your new levels when the player has went past the level, as well as controlling the speed of the enemies as the levels goes higher. Yeah. So let's go to the script in the game controller. Yeah. You can also access it through having the scripts and then game controller. Yeah. So now we're in here. I have quite a few public variables here. The first being the enemy, which I have assigned it to. Oh yeah, there's the game controller here. I've already attached the script. Make sure to check on this script so it's active. Yeah. Again, you can access this hierarchy by going to scenes, under game folder, going into gameplay. Yeah. So in the game controller, just set the script as active. So the enemy, I've set it to ghost. which is a prefab that I'm going to instantiate in the scenes for them to navigate to the player. Yeah. Then next is the new level. This new level is if you open up canvas, under this canvas, this new level. If you double click on new level, you can see that it brings you to this screen. So setting active means just showing this. If I set it inactive, you can't see the text, you can't see the panel. Yeah, this panel is just to have the effect of just letting the player know that it's a new level. Yeah, then this level itself is the text. Yeah. So that's what this new level object is for. It's just setting active and inactive at the respective times. Yes. Next would be the level scale. I set it 0.5. It's completely up to you. You can set higher or lower. And next, I have this array of positions. To define this as an array is just this square brackets here. So it means that it contains, just a list of elements, a list of, in this case, vector 2 elements. Vector 2 is just x and y axis. Yeah. And these are the positions that I will be spawning the ghost at. So you'll just pick one of these random positions. We manually set it in this case, but there are definitely better ways to do it. But for now, you'll just pick a random position out of this. Then the ghost will just be instantiated at that positions. These are just the corners, the parameters. And the next is the level text itself. Yeah, this is the under new level, then it's just to show which level is the player at. Yeah. And I have a private, it's just a list of clones, which I'll be elaborating on later. So for when the game starts, I want to definitely set the player score to be 0 because we have not started. So I'll reference to player data and the elements or the property score goes to 0. After that, I'm going to start the 2 routines that I've set earlier, which is level duration and the spawner. Yeah, so let's just start routine. And level duration, I already defined it. And as well as start this other routine simultaneously, which is a spawner. Yep. So if we go ahead and look at level duration, it's just a coroutine that has this while loop already. So because the level keeps going on, so I want it to always be running until the player has died. So I set while true. Yeah. And when the game starts, the very first thing I want to show is obviously this this new level, right? This panel and the text, because then it shows which level they're at. Yeah. So but before that, I want to freeze everything in the game. And how do I do that is I set the time scale to be equals to 0. This essentially freezes the in-game time. Yes. And after we freeze the game, everything has stopped, the player cannot move and so on. Then we set the new level to be active. So this statement itself basically checks the box here. So if it's unchecked, then it will check the box to show the text and the panel. Yeah, so this is what the set active function does. And after that, I want to set the level the text itself to be equals to level, space close, and it's gonna be reference to player data dot level count, which shows the current level. So this just shows the text itself. Yes. If you save now, let me set it as inactive. I'm just gonna press play. Wait. Oops. Just give me a second. Please don't actually do that. I forgot that it will just keep running and running, so that's why it overflowed. Yes. Okay, so let's go back to the script. Yeah, so the text will display the corresponding level. And then I want to have the player to be allowed to read the text for a specific amount of time. So I'll say yield return new wait for seconds. But it's not just wait for seconds this time, because if we use wait for seconds, then it will forever be stuck here. Why? Because we have set the time scale to be 0, the in-game time scale. So in this case, we want to use real time for maybe 2 seconds for them to read. And then after 2 seconds, we set everything as inactive again. So new level dot set active will be false. And time scale will be equals to 1. So yeah, after 2 seconds, the panel will disappear. The level will also disappear. Then everything goes back to normal. Yeah. So as for during the gameplay, this level duration does not actually do anything. So I'm just gonna yield to a new wait. Oh no. Wait for seconds. Or maybe depending on how long you want the level to last, maybe 10 seconds. Then I'm just gonna close it. Yeah, that's all during the gameplay. And after the gameplay, we wanted to locate all the ghosts and destroy them, because it's a new level. So I want to reset the level. Yeah, basically clear all the ghosts and reset the player's position to the middle, so on. And how do we do that is, I've already defined this clones. It's an array of clone that we have generated. But how do we know that, or how do we locate all of them, right? So we do that by using setting clones to be equals to game object with the capital G, because it's not referencing the object that contains the script. So it's the game object. Find game objects with tag. And because the tags are ghosts, so I'm just gonna find every object in the game, in the scene, that has the tag ghost. And therefore it forms our array of clones. Yeah. Then to destroy all of them, I'm going to run a for each loop. So this for each is basically to loop through this clones array and destroy them one by one. So game object clone in clones. For every clone in the clones array, I'm going to open up, I'm going to destroy. So essentially, this is how you get rid of every single one of them, by destroying one by one through a loop. Yeah, so every clone in the array that we have found of all the ghosts, we're going to destroy them one by one. So after we have destroyed them, don't worry, I'll give you some time after this to catch up. Yeah, so after we have destroyed them, we want to set the level back, or rather increase the level, because after the 10 seconds, then that means they kind of pass the level. So I'll get the level counts to increment by 1. Right? And after that, I want to this scaling is actually up to you, but for today I set it to the exponential scale for the enemy speed. So let's go back to the slide. Yeah. So this is actually the scale that I've set for today. It's just e to the power of x. Yeah, to make it slightly more fun. So as level goes on, then the enemy speed gets increasingly faster and faster. Yes. Yeah. So if you, okay, wait, I'll just code it out for now. So I'm gonna set a variable scale to be equals to math, the math function of exponential graph. And I'm gonna raise it to the power of level scale. Level scale is the 0.5 that we have set earlier. It's oh wait, it's in the inspector menu. Yeah. Then multiply by the player data dot level count. So it scales with the level. And because level count starts from 1, I just want to like -1. So don't worry about this line. Essentially what it does is just here. It's just e to the power 0.5x minus 1. Yeah. So this is just a graph. It's just the simple equation here, this expression here. Yeah. And after we have gotten the scale, I want to increase the enemy speed. So I need to reference to the enemy speed first. Therefore, I do enemy dot get components. I want to get the path finding and AI path, because in the AI path itself there is the variable called max speed. It's called, and I'm gonna set it to be equals to 0. So as the level increases, then the scale increases, then the speed also increases by this scale. This is how we increase the speed of the enemies. Yeah. And finally, I want to reset the player's position. So this is just another way to reference to the player. I'm gonna find object of type, because player is the only object that has type movement script. It's the only object that has movement script. So find the object of type move, and I'm gonna get components of the transform. I'm gonna set the position to be equals to just new vector 3, 0, 0, 0. So it resets the player's position to the default, the center of the screen. Yeah, this is just a way to reference to the object, and then I get the transform component, and I reference to the position specifically, which is, yeah, then I set to 0, 0, 0. So this is what the level duration does. Yeah. And you can take some time to catch up. If you have any questions, yeah, just ask. And you can also reference to the code snippets. Yeah. Just give like maybe another minute. Yeah, so once we have done the level duration, let's see. Yeah, should be fine. Okay, so now for the spawner that is running simultaneously to the level duration, I'm gonna set the position for the ghost to spawn first. So for us to do that, we have a we're gonna set a random index. I'm gonna call this of type integer index, and I'll use the random function dot range from 0 to 12. So this is just a function that generates from 0 to 12, 0 inclusive, 12 exclusive. So what this will do is that if you go to game controller under positions, it will locate, like it will just generate one of the numbers and then we'll reference to one of these positions. Yeah. So after we have done that, I'm going to generate the ghost first. So I'll use instantiate. Again, I'm going to instantiate the enemy at the position that we have chosen. So I'm going to use positions, square bracket syntax. It's just the syntax to get one of the positions here. Yeah, according to index. So if it's index 0, then this 1. Yeah. So at one of these random positions, then because instantiate also takes in the last parameter, which is rotation. So wait, sorry, what? So we have the rotation. Another way to have the rotation to be set to 0 is this thing called the quater identity. Don't worry much about this term. In essence, it's just rotation, 0 rotation. Yes. After we have instantiated, I will scale the spawn time with the level. So I will set the variable again, scale equals to. But now I'm gonna use another like math exponential function. Is level scale or rather divide by. For this scaling, we can just make do with a linear one if you want. Yeah, but for now, our level counts. Yeah. So what this line is basically this graph. It's just 1 over e to the power of this. And yeah, as you can see from the graph, as you progress on the levels, then the time to generate the ghost will be shorter and shorter and shorter. Yeah, so that's the scaling part. After I've done that, I need to yield return again to wait for a number of seconds before we spawn the next ghost. Wait for seconds. But this time around, we set it to scale because the time now is not fixed. It's going to be according to the level, and yeah. And that's how we kind of scale the frequency of the spawn. Yeah. So you can take some time to catch up. I'll give like maybe 1 to 2 minutes. Okay, so if you are done with spawner and level duration, I believe we can press play. Yeah, and yeah, as you can see, when the level started, then there was like this freezing frame, right? And that is the essence of freezing the time. Yes, I set the time scale to be 0, and that's why everything froze. And after like 2 seconds that we read level, then everything is set to normal. Yes. And then we wait for 10 seconds, and it's gonna repeat. Yeah. So if you go through them line by line, you understand that this is how. Oh, okay, sorry. So notice how like there's this bug where I shoot to the right and it does not fire. It's because in the weapon script just now, I think I set it to too near to the player itself. So instead of 1, I'm just gonna, instead of 0.5, I'm just gonna set it to 1. So the bullet is instantiated a little bit further from the player. So if we click on play, yeah, now it's able to fire. Reload it. Sorry. Yeah. So that's all for the game controller. That's the scaling. Yeah. Then next here we'll be going through, I think, the final part, which is the game menu, which displays like the high score, yeah, and the play game button.
Okay, can you see my screen? Oh. Okay. So that whole chunk of things is the gameplay. So now technically you have a game that is actually done. You can actually play the game in gameplay. But for a game to be complete, there should be some kind of menu where you can start and then somewhere you can see your scores and then at the end, like play again, that kind of menus. So now we are doing the game menu. So the game menu is quite simple. What it relies on mainly is the menu controller. What this does is, so at the start, you'll toggle between the start menu and the end menu. When it's the beginning of the game, then you will be the start menu. When the game ends, you will be showing the end menu. Okay. Then you'll load the game when you press the play button. And then at the end, if you die, then you will show the end game menu that displays the high score and your current player score. Okay. So how does that work? Now, go to the assets, go to scenes, go to game. You will see this game menu. Okay. Right now, the game menu sort of looks like empty. But when you press play, you'll be able to see this end menu here. It looks something like this, but you can't really do anything on it. So that's the end menu. You can also see the start menu. So if I turn this off and I turn this on, this is the start menu. Okay. Right now it does nothing, which is understandable. So first, go to the menu controller in the game menu scene. Then go to the menu controller script, and then you edit the script. So right now we are declaring two game objects, which is the start menu and end menu. And you can see here, we assign it to the start menu and the end menu. Okay. Then there's this text, which is the high score and the game score. They are sort of like text boxes that will be displayed. Yeah. So this text box is assigned to this high score for high score. Then the game score is inside the end menu. This game score is assigned here. All right. So at the start, just now the flowchart, you see that it's a toggle between start menu and end menu. So how do we toggle it? It's actually quite simple. It's only setting things on and off. So what we need to do is we check whether the game is started or whether the game is ended. So let's check, or we reference from the player data and check the game status. If it's equal to start, then what do? We toggle between the modes. So if it start, then the game the start menu will show, and the game then an end menu will be inactive. So start menu not stack active, and we set this to true. And end menu, we set this then if we do another if statement, and if the game status is end, then just basically the other way around. This one becomes false, this one becomes true. That is the toggle. Yeah. So we have the screens, but we actually don't know what the scores is going to show. So now after the game, if the player score is higher than the high score, then we assign the player score to become the high score. So it's also quite simple. So it's another if statement. If the player data score is greater than player data dot high score, then we just assign it. So player data high score is equals to player data score. All right. But this is only assigning the variable. It doesn't actually display on the menu itself. So to display it in the menu, we are going to use the text objects that we have just now. So we can see this high score and game score text object. So first, let's refer to this. So high score text opens up the text displays of this thing, and we assign it to, let's say, to display high score is 2, and at the value of the high score. So player data score, and then we need to have this function called toString, because as you know, high score is actually an integer, but we are displaying a text, so we need to convert the integer to a string. So that's why we need a function called toString. Okay. Then we do the same thing for the player current score. So it's game score. And we set this to just score. Always remember the semicolons. So that is the sort of like the inside the start function. Then we also need the buttons to, when we press the button, we need to redirect to the gameplay. So this function does that exactly. So it's actually just a line. It's just scene manager. Load scene and you just load the game plays. Okay. So that is the menu controller. So what this does is when we run the scene, you can see this is the start menu. Then when you press start, so when you press start, it actually redirects you to the gameplay, and you're able to play the game. And once you die, it redirects you to the end menu and display the scores. Because you are first time playing, so the high score is 4. So why the button works? Inside the start menu, you see this start button. This start button refers to the button when we click. So the start button has this component called button inside. You can see inside the inspector. And under this, there's this function on click. That means once you click it, it runs this function. And I map this function to the start game function, which when you refer back to it, it redirects you to the scene. Similarly, at the end menu, in the play again button, the button is also assigned to the start game, because play again, you actually start the game again. So that's how the buttons works. So in essence, once this is complete, we actually have the full game done in around 3 hours, a bit more than that. So those who have been following along, y'all are really amazing, because I must agree that the content is actually very quite deep and confusing. Because this, although it says an introduction, it's actually not really an introduction to Unity or introduction to C# programming. It's actually the introduction to developing a game itself, the game development. So all the things that we introduce to you are common things or components of a game that when you make your own game, you actually experience, like making the movement, scaling the difficulty of the enemy, making the enemy follow the player, and things like that. Shooting also, yeah. So we would like to thank you for being with us for all this time, such a long time. And if you want any resources, we have additional resources that we highlight to you that are quite good. So there is this Unity Learn, which is the official Unity resource that you can actually go and look at. It's mostly videos and isn't something like a course sort of thing. Yeah. Then there's a YouTube channel called Brankies. He makes a lot of short tutorials on like different elements of the game, like movement, pathfinding, all those, ray tracing if you want to know, yeah, all those. And then a tutorial that also introduce you to how to make the game. Yeah. And if you can't really follow along and you want to just mess around with the game when it's in a complete state, we have a completed project inside this link. You can click into this link to see and know more about like what places is you find confusing, and you can like look through it again. Yeah. And if you cannot get the game to work, it's the resource that you can go to. Yeah, or you can watch this whole course on YouTube again if you have the time to try out. Yeah. So that's all, and we thank you for being here, and hopefully you have enjoyed our course. Yeah.
Yeah, so this is like the end of the workshop. for those of you who want to clarify things, you can stay back. Yeah, then for now, I think we'll pass time to the admin for post-workshop reminders. Yeah.